Hello and welcome to my channel. I am Mensah Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we're going to look at how to solve this problem. Thanks to Mustafa from University of Ghana, Legon, for sending me this question. Richard also sent the same question, and Ebenezer also sent the same question. So let's see the solution to the question. Given that cosine of y equal to x times cosine of a plus y, so that y equal to the inverse cotangent of x times sine a divided by cosine of a minus 1. Hence or otherwise, show that the derivative of y with respect to x equals k divided by 1 plus x squared minus 2x times cosine of a, provided k equal to sine a. Now, there was a mistake in the question that you people sent. The mistake was that here was written as x cosine of a, but it is not cosine of a, but it should be sine of a. Yes, I have some small headache, so my voice has changed. Now let's see. Here we take cosine of y is equal to x times, now let's expand this. I'm going to have cosine of a times cosine of y minus sine of a times sine of y. This is cosine of y equals x times cosine of a times cosine of y minus x times sine of a times sine of y. If you want to understand how we expand this, check the description for my video on the angle sum formula for cosine and sine. Now, what do? We have cosine here and cosine. So let's group the cosine terms. So here I'm going to have x times sine of a times sine of y equals x times cosine of a times cosine of y minus cosine of y. Now we are going to have x times sine of a times sine of y equals cosine of y times x times cosine of a minus 1, as if we factorize cosine of y out. Now, what can we do? Here we have x times sine of a equals cosine of y divided by sine of y times x times cosine of a minus 1. That is, if we divide here by sine of y, the sine of y will cancel the sine of y, and we have x times sine of a. If we divide the whole of this by sine of y, it is the same as dividing only this by sine of y. So that is what I've done. Wow. And I have x times sine of a equals cotangent of x times cosine of a minus 1. Somebody is still saying, say, why need to divide the whole of this? Yes. If you have, let's say, 3 times 2, all divided by 3. you can write it as 3 divided by 3 times 2. So if you have if you have cosine of y times x times cosine of a minus 1, all divided by sine of y. It's the same thing as writing it as cosine of y divided by sine of y times x times cosine of a minus 1. So you should take note of that. And cosine of y divided by sine of y is cotangent of y. Now, I want to divide both sides by x times cosine of a minus 1. So here you get cotangent of y is equal to x times sine of a, all divided by x times cosine of a minus 1. That is, I've divided both sides by x times cosine of a minus 1. Now, if I want y, this implies that y equals, I'll take the inverse cotangent of both sides. So that will give me inverse cotangent of x times sine of a divided by x times cosine of a minus 1. And that is to be shown as we have them. Now, let's check the derivative and see. Now for the derivative, we have y to be equal to the cotangent inverse of x times sine of a divided by x times cosine of a minus 1. Now, what are we going to do? What we are going to do here is very, very simple. So we will proceed by using the chain rule. Since this is a function of a function, we have the cotangent inverse containing this function. So you say that you should let u to be equal to x times sine of a divided by x times cosine of a minus 1. Which implies that y equals the inverse cotangent of u. So, what do we do next? Here, you take the derivative of u with respect to x and the derivative of y with respect to u. So, let's take the derivative of y with respect to u. The derivative of y with respect to u is equal to the derivative of the inverse cotangent of u with respect to u. And this is a standard derivative. Check the description for my video on how to differentiate the inverse tangent function. Now, this one will give me 1 divided by 1 plus x squared. Should put negative here. Yes. This is the derivative or the standard derivative for the inverse cotangent function. So we have u here. So I have to put u squared, not x squared. So this is the same as negative 1 divided by 1 plus, but our u is this. So you put x times sine of a divided by x times cosine of a minus 1 there. And then square it. But we have to simplify this further. So let's do our simplification. Now we have -1 divided by 1 plus x squared sine squared a, all divided by x times cosine of a minus 1, all squared. Remember that the numerator will take the square. If the numerator takes the square, sine a has to be squared, and you have sine squared a. X has to be squared, and you have s squared. And the denominator also will take the square. So now let's simplify the denominator here. Here, 1 is divided by 1. So here the LCM is this one. So you multiply this by 1, we are going to get x times cosine of a minus 1 all squared plus s squared times sine of a all divided by x times cosine of a minus 1 all squared. Yes, you see that if you divide this by that, you get 1. And if you divide this by this, you come back to this. So very simple. You take the LCM. 1 will go into this. You multiply it by and you get this. This will come and divide this 1. You multiply it by what is at the top, you get this. And remember that we have 1 at the top and it is negative. Very, very simple as that. Or you can put it here. Correct. This is 1 dividing all this, so -1 dividing. So since we have 1 dividing, this one will turn upside down and it will become negative x times cosine of a minus 1 all squared divided by x times cosine of a minus 1 all squared plus x squared sine squared a as the derivative of y with respect to u. Wow. So we've gotten the derivative of y with respect to u. Very, very simple as that. So now let's find the derivative of u with respect to x and then apply the chain rule. So let's put it here. The derivative of y with respect to u equals negative into bracket x times cosine of a minus 1 all squared divided by x times cosine of a minus 1 all squared plus s squared sine squared a. So we have this here, so let's clean this from there. Now we are good to go. Okay, so here for the derivative of u with respect to x, we are going to use the quotient rule. And for that, we differentiate the numerator and multiply the result by the denominator. So here, if you come to the numerator, sine a is a constant. So you take sine a times what we have here, x times cosine of a minus 1 times the derivative of x with respect to x. Yes. you differentiate what is at the top, but sine A is a constant, so you brought it here. So you only differentiate x and multiply the result by this. So that's what we have there. Minus x times sine of A times the derivative of x times cosine of A minus 1 with respect to x. All divided by x times cosine of A minus 1 all squared. That is from the quotient rule. Now, if we differentiate x with respect to x, we will get 1. If you multiply it through this, you will still get the same thing. So we have sine of A into bracket x times cosine of A minus 1. Then here, if you differentiate this 1, we are going to get 0. And if we are going to differentiate x times cosine of A is a constant, so we are not going to differentiate. If we differentiate this x with respect to x, we get 1 times cosine of A will give us the same cosine of A. So it will be left with negative x times sine of A times cosine of A. Very simple as that. You can check it out. If we differentiate negative 1 with respect to x, you get 0. Now in differentiating x times cosine of A, you write it as cosine of A times the derivative of x with respect to x. If we differentiate x with respect to x, you get 1 times cosine of A will give us this cosine of A. Wow. So we are going to have here as minus x times sine of A times cosine of A all divided by x times cosine of A minus 1 all squared. Now this will become x times sine of A times cosine of A minus sine of A minus x times sine of A times cosine of A all divided by x times cosine of A minus 1 all squared. And here what will happen? We are going to have positive x times sine of A times cosine of A will cancel negative x times sine of A times cosine of A. And the derivative of u with respect to x will now be equal to minus sine of A all divided by x times cosine of A minus 1 all squared. So now, if we want to find the derivative of y with respect to x, that will give us the derivative of u with respect to x times the derivative of y with respect to x. And that is the derivative of u with respect to x is minus sine of A divided by x times cosine of A minus 1 all squared times the derivative of y with respect to x is minus into bracket x times cosine of A minus 1 all squared all divided by x times cosine of A minus 1 all squared plus x squared sine squared A. And that this will cancel that. Very, very simple as that. And you'll be left with the derivative of y with respect to x will now be negative times negative is positive. So you get sine of A divided by x squared cosine squared A plus, Okay, you expand it here when I bring it here. We have x times cosine of a minus 1 all squared plus x squared sine squared a. Now we are almost done. We are almost done. So here the derivative of y with respect to x will now be equal to sine of a divided by, I'm expanding this one, I'll get x squared times cosine squared of a minus 2x cosine of a plus 1 plus x squared sine squared a. Now, how did I expand this one? You should learn how to expand it. If you have a minus b all squared, you take a squared. Then you take plus 2 times a times negative b plus, then you take negative b squared. You see that? So this one will give us a squared, 2 times a times minus 2ab, and this will have positive b squared. So here our a is x times cosine of a. So if we put x times cosine of a all squared, x will take the square, cosine of a will take the square. And here our b is 1. So our b is negative 1. So if we take 2 times a is x times cosine of a times b, that is negative 1. We are going to get negative 2x times cosine of a. And if we square negative 1, we get positive 1. So you should take note of that. Learn how to expand. If you can't expand using the shortest way, just do it as x times cosine of a minus 1 times x times cosine of a minus 1 and use the distributive property. That is, this will multiply that, x times x will give you x squared, cosine of a will multiply this will give you cosine squared of a, then this will multiply together minus x cosine of a, this will multiply together minus x cosine of a, negative times negative is positive 1, so if we subtract it from this, you get a negative 2 as we have here. So you should learn how to get there quickly. Now, let's see something. This is the same as sine of a divided by x squared into brackets cosine squared a plus sine squared a minus 2x cosine of a plus 1. So I notice that I have x squared and x squared, so I can factorize the x squared out, and it will be left with cosine squared of a plus sine squared of a. And from the basic trigonometric identity, we know that cosine squared of a plus sine squared of a is equal to 1. So we will be left with sine a all divided by x squared. Cosine squared of a plus sine squared of a is 1 times x squared will give me the same x squared minus 2x cosine of a plus 1. And we can rearrange this to get what we have here as a sine of a all divided by 1 plus x squared minus 2x cosine of a, and that is to be shown. Thank you for watching. Please like, share and subscribe to my channel. Bye bye.